Yeah, okay. So we have some short talks by some distinguished faculty here. Today, starting us off will be Melinda Bunton, who's professor and chair of health policy over at VU and VUMC, whichever it is. I'll let you get started. You're right here.
Great.
All right.
Thanks. I'm going to turn this one away, and hopefully I won't get too much feedback. So I'm Melinda Bunton. As you just heard, I'm a health economist. I'm chair of the Department of Health Policy at Vanderbilt School of Medicine. And I realized in coming to talk to you today, I was expecting a sort of a student crowd. And when I took my first job out of grad school, I realized that I had to choose an institution that would be able to handle the quantity of data that my research required. I actually ended up going and taking my first job at the RAIN Corporation because I was interested in studying the Medicare program. And because the studying the Medicare program involves studying the health insurance claims of millions and millions of older people and disabled people in the country, there were only a few places that could handle that volume of data. Now we don't have to worry about this so much. Now we have to worry about people being sophisticated enough to handle those data well and interpret them correctly. And so that is a different kind of data science problem. But I thought I would tell you about my most recent research using large volumes of Medicare claims data and what the policy implications of it are. And along the way, I'll stop and talk about some of the data science problems that we've encountered. But in brief, my talk will cover Medicare per-beneficiary spending trends and whether or not they're likely to persist. And I'll break things down a little bit by service sector, talk about beneficiaries with chronic conditions, and then have a little side note about prescription drugs. And the reason this is important is because you've probably all heard, maybe even heard within the past couple of weeks, when you read in the newspaper that the Medicare trustees now say that the Medicare, quote, trust fund is going to run out by 2026, that Medicare spending is unsustainable. Everyone's favorite word for associating with Medicare spending is unsustainable. And having been in this field for about 20 years now, I can say that no one throughout those 20 years has ever thought that Medicare spending was unsustainable. But as of 10 years ago, the Medicare trustees were predicting that quote, trust fund would already be exhausted. So what has happened is that we've actually experienced historically very low growth rates. And I'll tell you about that, and this probably comes as a surprise to many of you because of this continued mantra about unsustainability of spending. But first, I thought with this crowd, I'd better tell you something about my study cohorts and sample sizes, and just give you a flavor of what the data problems are when you're looking at Medicare data. So big picture, in the US healthcare system, we spend about $3.5 trillion per year. About a fifth of the US economy, a fifth of the GDP, 18% of our GDP is spent on healthcare. That amounts to almost $11,000 for every person in the United States. And in the Medicare program alone spends over $700 billion per year. Just let that sink in. It's like basically a fifth of the economy we're talking about here, and we're spending $700 billion a year on the care of people who are over age 65 or qualify for the Medicare program due to a disability. So when I want to look at spending trends in the Medicare program, I need to look at data on these beneficiaries, and I need to get some fairly detailed data in order to unpack what's going on under the hood. So for the charts that I'll show you now, and I only have 10 minutes, so I just chose selected charts from selected papers, I use a few different cohorts. One is that I use data on 100% of beneficiaries who are in the traditional Medicare program, which is called the fee-for-service program. They aren't in private insurance plans that care for Medicare beneficiaries, and people who are age 65 and older, because they're a more homogeneous group. And on average, over the time period I'm looking at, there are about 32 million of those beneficiaries. So my sample sizes of the period of data that I'm going to show you amount to about 300 million beneficiary years of data. For some types of care, like physician's office care, where beneficiaries may have dozens and dozens and dozens of visits, procedures, lab tests, et cetera, per year, we can only look at a 5% sample of those types of services. It's just so huge that no one can handle the data except for Medicare itself, and they just don't let researchers use it. They sometimes, if you make a compelling case, will give you access to a 5% sample. So we use that for some of our analyses. And then we wanted to look at trends in the care of people who are particularly sick, trends in episodes of care that were triggered by hospitalization. So for for one of the slides I'll show you, we just looked at inpatient episodes of care. And as you can see, there's almost 10 million of those per year. So that represents about 70 million observations of episodes of care triggered by an inpatient hospitalization. So right away, you can tell that there's just an enormous volume of data that we're dealing with. And I was told earlier that there is someone here from the company that's now called Change Healthcare, which is formerly called MDON. They're a company that probably most of us have never heard of because they do the back-end processing of health insurance claims, mostly for private insurers, and they coordinate between all the providers of care, like doctors, hospitals, labs, and the insurers that pay for that care. And I looked on their website earlier, and they said that and they're just one of many companies doing this, they processed 14 billion claims last year, amounting to over $1 trillion. So this is the volume of data that we're dealing with. All right, so to return to my story, after decades of very rapid increase, Medicare per-beneficiary spending had dramatically low rates of growth from 2010 to 2017. So this is the reason why the actuaries have pushed out that date of when they think this Medicare hospital inpatient trust fund will expire. So you can see here, comparing in the red bar, GDP growth, in the green bar, national health expenditures overall, and in the blue bar, Medicare spending per capita growth. In the 1990s, all of those were really high. In the 2000s, you can see that Medicare was exceeding the rate of growth for national health expenditures overall and vastly exceeding GDP growth, which is of concern because, of course, it's the productivity of workers who are currently working and paying payroll taxes that supports the Medicare benefits that we'll all get when we're older, hopefully. And then in the most recent decade, we had a striking turnaround. GDP growth was low. As we all know, we were recovering from the Great Recession. National health expenditure growth was low by historic standards in that green bar at 3.5%. But Medicare spending growth was even lower, about 1.5% per capita on an annual basis. Now, I don't want you to leave this talk thinking, oh, we've solved all of these problems, because we are still projecting that we're not going to have enough revenues to pay for hospital benefits starting within 10 years. And we also have the baby boom retiring. So those numbers I was just showing you were on a per capita basis, a per beneficiary basis. Overall, because of 10,000 baby boomers retiring per day, we still have immense growth that has occurred over the same period of time in the total amount we're spending for Medicare, and we are projected to have that. But in terms of things that policy can control, policy cannot control the number of baby boomers that are retiring. It's a wonderful thing that we have a large population and they have extended longevity. But still, over the time period shown showed on this prior slide, so from 2007 to 2015, total Medicare expenditures did increase 50% from about $433 billion to about $650 billion. And now they're at about $700 billion. So this is really tremendous growth over this period of time. But again, to return to the per-beneficiary spending, it's been relatively flat. And in fact, after I adjust it for the change in prices we pay for doctor visits, hospital visits, labs, et cetera, it really only increased 9% over this fairly long period of time. So our question for the research was, what's going on? So we used a type of decomposition analysis called a Oaxaca blinder decomposition. I don't have time to get into exactly how we did it. But after adjusting for the population change, the fact that younger beneficiaries were coming in, those 10,000 baby boomers per day, were bringing down the average age and thus the expected expenditures of Medicare beneficiaries. And we adjusted for spending levels, conditional on having diseases. We found that, all else equal, we actually would have expected spending, we actually found that spending decreased by about $180 between this early period of time and a later period of time. And most of that was due to what's in this larger middle bar in the middle. This larger bar in the middle here, which was that there was a decline in the prevalence in the population of chronic diseases. So this was one set of analyses we did, and we said we really have to dig into this and figure out why. And this is when we turned to creating data sets that looked at episodes of care triggered by an inpatient hospitalization. And what we found there was that there really had been a decrease in the rates of which beneficiaries are using the hospital, and in particular for cardiac conditions. Now, overall, we saw fewer of these inpatient episodes of care, but it was particularly pronounced for cardiac-related episodes. So this is a big part of the reason why we've seen this slow spending growth in Medicare. But we also saw that there was, and this is, these analyses are probably show what's going on in the privately insured, although we haven't conducted that work yet. We're proposing to do it now to see if there's been similar declines for things like circulatory diseases or endocrine diseases among the privately insured. But another piece of the puzzle for why Medicare spending growth has been low is because Medicare's prices have been increasing at relatively low rates, and they've been increasing at low rates compared to the prices paid by private insurance. So this slide shows you in the dotted lines the private insurance growth rate in prices, and in the solid lines the growth rate in Medicare's prices for inpatient, outpatient, and professional services, which are doctors and nurses in general. So you can see that Medicare's spending growth rate was attenuated both by these issues of population change, decline in hospitalizations for chronic diseases, especially cardiac diseases, and also by lower growth rate in prices, which was a policy decision made by Congress. So what does this mean for the future? We don't exactly know. I often try and prognosticate because it's important for us to understand the fiscal implications of any decision that we make about prices, spending, coverage, benefits, et cetera, for the Medicare population. But the trustees are predicting that growth will resurge in the future, and in particular, it will resurge for prescription drugs, which are covered under the part of Medicare called Part D. That's handy because you can always remember that Part D is for drugs. And in Part D especially, we're concerned about growth, really rapid growth in prescription drug prices for very expensive drugs that are coming on the market. So that's something we'll also be looking at in the future. So just in conclusion, I would love you to leave this leave this talk remembering that we've had decades of rapid increase, but on a per-beneficiary basis, we've been holding growth rates down. We've had fewer cardiac-related episodes of care. Medicare prices and policy decisions have really kept growth rate down, but we're still expecting a lot of future growth in Medicare due to, in particular, to prescription drugs. And I'm happy to take questions if there's time.
Thank you. Are there any questions over there?
As those lowering the Medicare age groups, like baby boomers, get older, do you expect the drivers of per capita costs, like the cardiac diseases, to grow?
That is an excellent question. So getting under the hood of why we think there's been fewer inpatient hospitalizations for cardiac diseases, part of that may be due, and there's some other research that I haven't personally conducted, but I've been reading recently about better cardiac prevention. So better, at this point, basic drugs for things like high blood pressure and lipids and things like that. So we actually have hope that that will be sustained because it seems like people at younger ages are being treated more aggressively with these types of relatively inexpensive drugs, and that's preventing cardiac complications.
Okay. Thank you.
Thank you.
Yes, so I'm going to talk about investigating gentrification and mobility in Nashville, and I'd like to emphasize here my graduate student, David Knorr. He's the one who did the work. I just get to come here and give the fun talks. And also, there were great contributions from 3 undergraduates who did immersive research experiences that led to their senior theses on this project. So if we look at changes in Nashville, we see interesting changes in housing. For decades, all the change was people moving out away from the center of town toward the suburbs, but starting in 2000, we started to see this reverse and a dramatic move back towards the center of the city. Many of us know our population in recent years was growing by an average of 100 people per day. And in this analysis, I'm going to be looking on changes from 2000 to 2016, and my unit of analysis is going to be the census tract. But before I dig into the statistics, I want to just look at what gentrification looks like. So this is from a tool my student David came up with that examines all the building permits issued in Nashville and automatically identifies teardowns where houses like these ones shown on top, the old houses in the Nation's neighborhood, are torn down and replaced with luxury homes. Then he's able to grab before and after shots from Google Street View. This is another shot in the Nations. We see similar things in the Edge Hill neighborhood and in East Nashville. So this is going on all over. And when you see these pictures, you can recognize, yeah, that's gentrification happening in our neighborhoods. But can a computer recognize gentrification? So I'm going to be looking at 3 questions here. The first is, can a computer distinguish gentrification from other kinds of neighborhood change? And then can we assess the connections between gentrification and mobility, especially for homes that are dependent on public transit because they don't have cars? And finally, can we predict which areas of town are likely to gentrify in the future? So classifying neighborhood change is tough. A lot of the extant indices for gentrification are rather subjective. Researchers pick a few variables, they define some arbitrary thresholds, and if the change happens to cross that threshold, it's gentrifying. If it falls a little short, it's not. And this leads to problems of interpretation and analysis. So we're looking for a different approach using a simple k-means clustering algorithm that works on 6 basic variables: the median home value, median rent, household income, educational attainment, racial composition, and the amount of multi-unit housing in a census tract. The user specifies the number of clusters, the computer automatically assigns census tracts to each cluster and adjusts the clusters for optimum compactness. And what we come up with something like this, a map of different types of neighborhood change in Davidson County. And then each kind of cluster is characterized by a certain pattern of change in each of our 6 variables. So the blue clusters, the census tracts in cluster 1, are characterized by a growth in the non-white population, a decline in the home value, declining rents, declining income, declining educational attainment, and a shift from single-family homes to multi-unit housing. That's the pattern. That comes out of the analysis. Then it's up to a person to look at that pattern and interpret it and say, well, what does this signify? And so one interpretation here would be, well, this looks like it may be areas of affordable growth where people of low income can afford to move because the home prices are becoming lower. But there's an alternate interpretation that potentially these are also areas in which we're getting concentrations of poverty. The second cluster, the census tracts in red, are very different. These are areas that are becoming whiter, wealthier, better educated, with higher home values, higher rents, and again, a bit of a shift towards multi-unit housing that may be luxury condos, luxury apartments, such as we see going up around town. Our third cluster, the green, are rather stable. There's not a lot of change. And the fourth cluster are a few census tracts that are kind of a grab bag of the ones that don't fit into our major clusters. So let's look a little more at the clusters I have interpreted as gentrifying. If we look around town in West Nashville, we see Sylvan Park and Sylvan Heights. Towards the downtown, we see Germantown and the Gulch. These are all places that are widely accepted. Yeah, everybody pretty much agrees these are gentrifying. You go a little south and you see Edge Hill, 12 South, Melrose. Again, a lot of gentrification and identifying a lot of neighborhoods in East Nashville that are widely accepted as gentrifying. So the clusters the computer's identifying agree with what general consensus is on gentrification. And so, in summary, we've come up with a way to identify types of neighborhood change without a priori assumptions, without ad hoc thresholds. And this method can be applied to different cities. So cities that are experiencing different types of change, this kind of approach can identify the types of change specific to that city. And finally, the kinds of areas that are identified as gentrifying fit with what the kind of common sense consensus would say. So having identified areas that are gentrifying, we then start to look at how this may affect mobility, particularly mobility by public transit. So we draw on the Census transportation planning product, which gives us essentially statistics on who commutes from where to where all over the country. And so we can identify commuting trips within Nashville and estimate the times for commuting. So for each census tract, where do people who live in that tract tend to work, and how long would it take them to commute by car, by bus, etc.? The map on the left here is a heat map showing commute times for commuting by bus, and the lighter colors are shorter times, the darker colors are longer times. And we see the shorter commutes, the better transit access is in the downtown, the areas where we're also seeing very rapid rates of gentrification. The people who are being displaced from there, who used to have good access to transit, are now being displaced to the blue areas in the map on the right, and that's where transit is much less accessible and the commute times are much longer. So we're seeing a real shift in people's ability to commute and also to do other activities of daily life by public transit. And we're pushing forward on trying to understand these relationships better. Finally, we look at, can we predict future gentrification? So we take our classification of neighborhood change that was changes between 2010 and 2016, and we say, can we predict those from data that was collected in 2000? We train a random forest model with 18 predictor variables, split our data into a training set and then a holdout set for out-of-sample testing, and we find the predictions, it's sort of a mixed bag. Our data is very unbalanced. Only about 13% of the census tracts actually gentrify. So when we look at predictive accuracy, the table on the left here, hang on a second. So the table on the left here, out of 34 tracts that were predicted to be not gentrifying, 33 of the 34 were actually did not gentrify. So that's pretty good. But out of 11 tracts that were predicted to gentrify, only 5 actually did. And this is a kind of common phenomenon when you have a very low rate of the thing that you're trying to predict. On the other hand, in terms of sensitivity, out of 6 tracts that actually gentrified, our model predicted 5 of them. So it's good at identifying gentrification, but it has a high false positive rate. The variables that turn out to be important here, distance to downtown's important. So think back to my first slide. Economic factors like unemployment, poverty, vacancy of homes matter. And interestingly, the next most important variable is how many families have 3 or more cars. So finally, what we do is we take that model that worked well at predicting gentrification in 2016 based on year 2000 data, and we feed our year 2016 data in and say, what does this suggest might happen in the future? And that's the map that's shown here to the right. The red areas are areas we identify as being at high risk of future gentrification, and that includes North Nashville up around Fisk and TSU. It includes an area along Charlotte Avenue that's already begun to gentrify since 2016, and it includes some areas that are already gentrifying like Edge Hill and 12 South that it expects to continue to gentrify. It also suggests that some of the areas that now are being affordable sites where people who are displaced from the urban core are moving to, those may start to gentrify and in turn become unaffordable, displacing the people there yet again. However, these predictions are untested. This is preliminary work, and take it all with a grain of salt and remember the very high rate of false positives that I showed on the previous slide. So this is all work in progress, but it gives a sense of how working with very large amounts of data that's available, in part because Nashville has some wonderful open data policies from the metro government, is enabling us to better understand change in Nashville and to start trying to think about how are these changes in housing likely to affect the quality of life of the people who live here. So thank you.
Have you thought about extending this to the whole country? How many regions and cities have open data policies like Nashville?
Yeah, not every city does, and we were inspired somewhat. There's Philadelphia, San Francisco have some very good open data, and also we are able to do a lot with just generally available data from the census. So we are looking at extending this, and actually this weekend I'm trying to finish a grant proposal to extend this to all of Tennessee.
So I was wondering if you could talk a little bit about how those features were chosen, and also is there any interest in just surveying the people and asking, do you think this area will gentrify?
I think crowdsourcing is a wonderful idea. It's a nice source of different data and also potentially a source of validation for this. Essentially, the features were chosen. We didn't do a lot of feature engineering and just chose pretty much raw data out of the census, out of building permits and home values and so forth. And we did a bit of just, trial and error and seeing what worked well. But we see, to a large extent, a lot of these things are fairly stable, fairly robust against choosing some different data. Some of the things we're interested in for the future is we see a lot of spatial correlation that we haven't paid attention to, and we're going to start working with spatially aware models.
A real quick follow-up.
Sure.
On the 3-car thing, which way did that correlate?
More 3 cars made, actually, sorry, this is a random forest, so it's not a regression, so there isn't a simple interpretation, so I can't give you a straightforward answer on that.
Thank you.
Hi, so thank you so much for presenting this. I found it absolutely riveting. You said that we should be skeptical about these predictions. So what do you think that you would need to do in the future to make it something that the government could use or something that could be actionable?
I think the key thing is thinking about how to use uncertain information responsibly. So if we can understand better what our uncertainty is like, then we can do a better job of informing communities and say, you may want to look at this, but don't, understand that we're uncertain about this. I particularly look to, I'm very inspired by Ken Stife, who does a lot of work in Philadelphia on how to use data and how to use machine learning approaches like this to responsibly inform neighborhoods and empower them. And so one of my thoughts here related to this is real estate investing companies are doing stuff like this all the time, and we never get to see this. So what I'm hoping is that this is going to enable us to develop tools so that community organizations can actually take control of these analyses and using the data, because I think that's really the best place for this to go, is when this is putting information and analysis in the hands of people rather than somebody like me simply telling people what it is.
Thank you.
So critical to any democracy is the actual ability to actually cast your vote and have it count. Right? Now, that's not always been the case. Right? The whole history of Jim Crow is the approach of systematically, don't quit. Right? It's trying to systematically disenfranchise people from that ability. So perhaps, thank you. So one kind of less prevalent way of thinking about this is the action of actually getting to your polls. Right? So one thing that election people can do is they can change where you vote on election day. They can change that to you, and that may make it harder to vote. And sure enough, every election, there's lots of stories about this precise activity going on. People who are controlling the elections, changing where you vote, and therefore maybe targeting some voters more than others based on their partisanship or based on their race. Now, this is obviously consequential, right, because it impacts the outcome of elections and even the ability for people to cast votes and have their voices heard. So here's just an example of North Carolina. Right? Here's Charlotte in Mecklenburg County, central business district here. And here's a bunch of all the precincts, because every single voter is allocated to a particular precinct, and each precinct has one unique polling place. So if we zoom in on precinct number 2, right? And we kind of look at what's going on here, and we overlay the racial demographics by census blocks. We can see that here's the shading of census block precinct 22 by whether or not the percentage of white versus non-white voters. And so since we have a well-known correlation between race and partisanship, we can pretty much predict the impacts of kind of how people are going to vote based on that. So in 2008, right, the polling place was located in the kind of the whiter part of the precinct. The Democrats were in control of the process between 2008 and 2012, and it was moved across the precinct. When the Republicans took over, right, in lead up to the 2016 election, it was moved back to a different part of the precinct. Right? Now, this is just one example, but it raises the question, given everything that we know about our politics, is that whether and to what extent do local officials make such changes more systematically? Right? Are they locating precincts to kind of change and to impact different types of voters differentially? Now, obviously, this is really hard, right? We don't know actual motivations. So instead, what we need to do is try to leverage as much data as we possibly can and try to triangulate in on the question to kind of see, is there evidence consistent with officials targeting particular types of voters based on their race or their self-reported partisanship? So let's think about North Carolina. North Carolina is an interesting case for a number of reasons. Right? So one is that all the elections are made by three-person boards, all appointed by the governors, of which two is in the same party as the governor. Those three-person boards have exclusive control over where the precincts are drawn and where the polling places are located. Right? So these are partisans who are in control of the process itself. Moreover, North Carolina is particularly close. President Obama barely won it in 2008, and in kind of lead up to 2016, right, it was called the swingiest of the swing states, whatever that means, right? But both parties knew that the stakes were high, and so if ever was going to see an instance of this activity occurring, we would think it would probably occur in North Carolina. In particular, people are not always smart with email. So this is an example of the Republican Party in North Carolina, the journalist found, actually giving instructions to county board members to basically make straight party line changes in terms of how elections are being administered, right, in relation to early voting sites, right? So not only is there the demand to do this, right, it's a very close election, but we also have evidence of at least state parties telling their members that you might want to think about doing this kind of thing when it comes to kind of early voting, right? So the question is there evidence of how much has happened, right, and can we quantify the effect that this is going on? So what did we do to test this? So what we did is we kind of took all the voter file records that exist in North Carolina to create a balanced panel from the 2008, 2012, and 2016 election. Right? So we basically take all the voter files and figure out who's eligible to vote over the entire time period. Right? Now that's important because that means that anyone who experiences a polling place change, they're experiencing a change not because they move themselves, but because the election administrators are changing their own circumstances. Right? So we're able to isolate the impact of who's experiencing a change because of the actions of election administrators themselves. Right? So moreover, because of the consequences of North Carolina, it's such a close state, we have variation in the party in control. So from 2008 to 2012, any change in your polling place was made by Democrats because the Democrat was in control of the state, the Democrat governor. Now, when the Republicans were elected, though, that means any changes made between 2012 and 2016 were made by Republicans. So we can compare how the actions of Democrats when in control compare to those of Republicans and whether or not they performed similarly or differently. So what do? So we have every single voter that lives in North Carolina. We have their address. We have their name. We have their race. We have their party registration. And because we have their address, we can also get the shape files of every single precinct to identify what precinct every voter lives in and whether those precincts are changed. We can also find the actual physical location of every polling place in these presidential elections to basically figure out where the polling place is in each of these precincts. Moreover, because we have the geographic information, we can geolocate every single voter vis-a-vis their polling place in their district, right? And we can use the Google API to kind of actually figure out distance from each voter to their polling place, not only as crows flies, but also in terms of travel time. Right? And we can kind of see how that is going to be changing in response to polling place changes that they are experiencing because of the actions of election administrators themselves. And then we can think about three different outcomes, right? Whether or not you experience a polling place of any kind, whether or not your polling place has moved closer or farther from you, and also just the number of voters that are voting at your polling place. Thinking about if there's more voters, there's more likely to be lines, it may be harder to kind of vote. So to try to figure out, is there any kind of evidence that election administrative officials are doing this, what we do is we look at the differential experience of different types of voters, right? So if we think that, do we find evidence that if I'm a Democrat, I'm more likely to change the polling place of a Republican than I am to Democrats, thinking that the natural need to change a polling place is probably not associated with partisanship. Now, we can do the same thing with race as well, right? So the critical question is, are voters who are affiliated with the opposite party of those in control more likely to have their polling place changed? Because we know that voters who have their polling place changed are less likely to vote because of the costs that are involved. Right? And so we can look at all this lots of different ways. We can look at it for the entire state to get the statewide effect. We can look at it county by county to see if some counties are more likely to do this than others. In particular, we can focus on the set of politically responsive counties, those counties that journalists and kind of activists have identified as being much more likely to engage in such activity with respect to early voting. And then we can also kind of use leverage from a Supreme Court decision that removed the ability of the Department of Justice to basically oversee these changes and basically opened up the floodgates so election administrators could do whatever they wanted without getting the approval of the Department of Justice. And so what does the data look like in the raw? Right? So these are, again, people, the 2.5 million people who are stable. They don't change their residential status. And what you can see pretty much immediately in the raw, not much there. Right? So in particular, if you look from 2008 to 2012, when the Democrats are in control, if you look at Democratic voters, about 16.88% of Democratic voters experienced a change in their polling place, as opposed to 16.01% of Republican voters. Right? Similar if we think about black voters versus white voters, black voters slightly more likely to experience a change, but again, that's nothing to write to your grandmother about. Right? There's not a huge difference there. Right? And similarly, if we look at when Republicans are in control from 2012 to 2016, right? Again, not any real evidence that Democrats were more likely to be targeted by Republican changes, or black voters were more likely to be targeted than white voters when Republicans were making change to election day polling places. Right? But this is, again, the raw. We can do all kinds of crazy things to kind of control for this, which we do. But here's just a summary of kind of what's the effect, county by county, of the probability of an opposition voter being targeted by Democrats, right, on your left, and by Republicans on the right. And what you see is that some places like Alamance County had no changes, so there's no estimate there. But then you see sometimes in some counties, opposition voters were more likely to be targeted, right? And sometimes they were less likely to be targeted. And moreover, the median one is basically straight on the zero line. So in particular, if we aggregate those up, now that was just a subset of the counties, but over all 100 counties, you see something that looks darn close to a normal distribution, right? Which is to say that when Democrats are in charge and when Republicans are in charge, right, the probability of having your opposition voter experiencing a large change was as likely to have be kind of positively associated with that as it was to be negatively associated with that, right? So it looks like there's nothing really systematic going on in terms of the likelihood of an opposition voter being targeted by either Democrats or Republicans. Now, maybe that aggregation is kind of hiding that there's some kind of interesting covariation there. I wish it was the case in terms of for my publishing of the paper, but unfortunately not so much if you actually look at all the covariates, right? So if you see, well, does the probability of being targeted by a party covary with how democratic the area was? Answer, no. The percentage of kind of non-white, in particular, the percentage of the share of the black population in the county, no. Those are all flat. How about whether or not swing, right? Or at least they're smart enough to focus on kind of swing counties that could swing the election? Not so much, right? So what you see is time after time after time, and this entire paper is full of null results, right? It's very, very hard to find any evidence, there's systematic evidence there, at least on election day polling places, that there's systematic targeting by either race or by party registration status, where they're kind of more likely to target those voters that are opposition for themselves, right? So regardless of how all the analysis that we do, right, and even when you control for multiple testing, we can find no systematic evidence, at least on election day voting, right, that people who are or less likely to have their election day polling place changed, right? And so moreover, I think there's really important implications for election forensics literature, which is this kind of fancy thing that we try to say because it sounds like CSI and makes it more like an attractive topic. But like, if you look at any one locality, right, it's possible to find big effects, right? And lots of the literature does exactly that. They say, well, they've got this one county, and I can show you that the opposition voters were much more likely to be targeted in this county than the non-opposition party. But that's potentially very, very misleading. And when you take a step back and look, well, what's the entire thing look like statewide, right? Those isolated instances kind of fade away to the background. And so it's really hard to make generalizable inferences about what may happen in one particular county or one particular city without taking a step more broadly to kind of figure out, well, is that effect really real, or is that just kind of a statistical artifact? So thank you for your time. Democracy is safe.
The bathrooms have been moved to the other side of the
So this accounts for whether that's in some sense the dependent variable, right? So is your precinct boundary changed such that you have a different kind of polling place? And so we're looking at presidential election years to try to hold fixed the electoral context. So these are all kind of close swing, state elections. But yes.
Okay, so given that politicians are very motivated to win elections, and you've shown that at least some politicians want to do these things, does the fact that they don't seem to actually be doing it mean that they're dumb or incompetent? I mean, how would you interpret the fact that people who are highly motivated are not doing these things?
So there's a couple things. So one is that there's still other ways. So I didn't look at the number of voting machines. So it's possible that they're focusing on early voting hours and not election day voting. But it's so it's hard to know exactly what's going on. But it's also possible that maybe they're not as bad as we think they are, right? And so maybe they'd be bad if they're trying to target and they're failing, right? But maybe they have a genuine concern, like there's some things that are out of bounds, which may seem weird in our politics nowadays, that you might not do something just because you can do it, right? But maybe that, at least on this level, there's access to the ballot box and changing polling place locations, that for whatever reason, even though they can do that, right, because they have all this data, right, but they choose not to because it's not the right thing to do. Now, that requires morality, which is always hard to attribute to politicians sometimes, but that's a potential explanation of kind of what's going on, and I can't rule that in or out.
All right, thank you.
Awesome, thanks.
Hi. So I'm happy to introduce Andrea Ramirez. She's a professor of medicine, and she's going to talk to us today about challenges and promise in precision medicine.
That is working. That is working. Okay. All right. Hi, everyone. I'm an assistant professor of medicine. I appreciate the upgrade there, but much more junior than that. So hopefully we'll stay under 10 minutes here. I'll keep an eye on my timer. And we're going to take a little historic look and look at the past and kind of the future I see for precision medicine. So I spend the minority of my time in care of endocrinology patients, and the majority of my time as the director of the Precision Medicine Initiative data science team, and that's why I'm here today. So I was thinking, precision medicine and data science, what two huge buzzwords, which one's more popular? And you guys, data science really swamped us in precision medicine. So the red line is data science, the blue line is precision medicine. So forget data science and let's take a closer look at precision medicine. You'll notice a funny bump there. One of the first challenges precision medicine hit was, what do you call it? So here's a comparison to personalized medicine and kind of showing how these two terms were duking it out. And something really important happened where this inflection point is seen. It was January of 2015. We've been talking a lot about politics. It was the State of the Union address. And it's shown here when President Obama introduced in the State of the Union what's called the Precision Medicine Initiative. And the quote was, "I want the country that eliminated polio and mapped the human genome to lead a new era of medicine, one that delivers the right treatment at the right time. So tonight I'm launching a new precision medicine initiative to bring us closer to curing diseases like cancer and diabetes, and to give all of us access to the personalized information we need to keep ourselves and our families healthier," which sounded wonderful, got a lot of applause on both sides of the aisle, great for funding. But a lot of physicians said, hey, wait a second, that's what I do already. What's the big deal? In medical school, I had this wonderful mentor, Dr. Harmel, and he liked to quote Osler, shown at the top, because he said he was his contemporary. He was born before Osler died, and would talk about how, as doctors, we needed to observe, get the patient in a good light, let your word be your slave and not your master, and really drilled these things into us. And so we, by the time it's the 2000s, we're doing this pretty well, right? But it wasn't the 1940s. So let's think back to only 70 or so years ago, what was going on then. This is a very famous picture of, hopefully everyone recognizes FDR. Sometimes some of the undergraduates miss Stalin, but it's FDR, Stalin, and Churchill. And around 1945, he was at this conference in Russia, and when he had become president earlier, about a decade earlier, his blood pressure was 140/80, which was considered normal. Even as it rose to 180/110 midway through his presidency with a tiny little world war going on, no one thought it was unusual for someone his age. But by this year at the Yalta conference, he had started to see a cardiologist the year prior at his daughter's insistence, who had found he had very advanced heart failure for which there was no real treatment at that time. And Churchill's doctor at the Yalta conference actually said, "I think that guy's about to die. You know, what's going on, America? You don't realize your president's really sick." And sure enough, 2 months later in April of 1945, when he was sitting for the portrait shown on the right, he had blood pressure of 300/190 was recorded and died of a massive cerebral hemorrhage. And that really reflects on how little we knew at that time that blood pressure was bad for people and what really led to cardiovascular disease. So shortly thereafter, the Framingham Heart Study was founded. Really, his death, while tragic, was the impetus for Congress devoting funding to study what really is going on with cardiovascular death, which accounted for 50% of mortality at the time. So they enrolled around 5,000 men and women, primarily Caucasians, in the small town of Framingham, and followed them for over a decade until some of their first discoveries that we take for granted now. Cigarettes increase heart disease, et cetera. Exercise decreases risk of heart disease. And it really changed our outcomes and our outcomes in medicine. You can see how these mortality rates really fell off after we started thinking systematically in an observational prospective cohort study about what's going on. So what's different now? What's the big deal? Why do we need this precision medicine initiative? So they had blood pressure cuffs, which strikingly still look the same. But today we have this entire human genome. And there's been a lot of promise put behind the human genome. There were cartoons like this showing a woman taking her genome sequence to the pharmacist and saying, "Give me a drug based on this." And what's remarkable, this was the year 2000. We're almost 20 years later now. That's not happening in routine practice. Vanderbilt's been a pioneer in this area. Many of you know they have one of the largest, I think the largest biomedical informatics department in the country. Brad Malin, who may still be here, helps lead this institute and has been an integral faculty member there. And what Vanderbilt also pioneered was the use of electronic health records, creating their first records in the 90s. And with all the data gathered, all that observation, asked the really fundamental question, how can we use the EHR for research? And what they developed was a really important system program known as BioView, where those records that we had for Mr. John Doe were de-identified with a one-way hash into a synthetic derivative, creating a de-identified database of information. And the innovative part was then taking the blood. So when Mr. Doe went in for his annual visit and had his lipids checked, the blood sits in the lab for 2 days while us doctors remember to order the tests we forgot. And after that, it's discarded. And so instead of discarding the blood, Vanderbilt put in place an IRB to take that discarded blood and extract the DNA. And then by that means grow a DNA data bank with 250,000 DNA samples linked to medical records. That had really never been done before. It was one of the first and fastest of its kind to grow, and that's when I was actually an intern here training in internal medicine. So what we tried to do then was find phenotypes in the data that we had using all of the data available, so billing codes, clinical notes, medications, labs, and tests, to find those true cases. But you never get it right the first time. This is an iterative process with a lot of loops in the middle. But looking for high specificity generally in these cases, you don't know what you don't know, so the sensitivity is often low. And that kind of approach really facilitated two really important studies that I don't have too much time to go into detail on, but on the top showing a genome-wide association study where you take a known phenotype and look at all of the genotypes and try to find which of those genotypes are associated with a phenotype, versus a PheWAS study, or a phenome-wide association study, looking at one variant genotype and then doing a phenome-wide phenotype to find which phenotypes were associated with that gene. So two really important processes that have helped move precision medicine forward. And the NIH took note of this. They said, let's fund a lot more places to do this kind of research, and founded this eMERGE network. So again, why do we need this precision medicine initiative? And precision medicine initiative went on to be defined at that time by the government, this emerging approach for disease treatment taking into account individual variability in lifestyle, environment, and genes. And what I really hear here is that the difference is the data. So we don't just have a blood pressure cuff, we have this genome, and we haven't moved effectively into patient care on how to handle that huge volume of data that no one's brain, no matter how many tests in medical school you take, could ever hold. And so a working group was convened, including many at least one very important faculty member from here at Vanderbilt, Josh Denny, where they designed a 1 million or more person cohort that would be longitudinal, recontactable, 1 million, not just 5,000 in Framingham, from diverse backgrounds with a focus on engagement to keep these folks engaged over the long run. And put out funding opportunities shown here. The top left, the Data and Research Center, Vanderbilt was awarded and works with Verily and the Broad Institute as partners in this initiative to perform the big data capture, cleaning, and curation. So volunteers sign up online, they have a health assessment visit, have urine and blood samples provided, and then they answer questions every year. They also consent to share their electronic health records, so similar to the approach we took here at Vanderbilt to create the synthetic derivative, we're taking electronic health records from around the country and pulling them into the database in the Precision Medicine Initiative. There are many enrollment centers around the country shown here and planning more. Around 200,000 people have enrolled so far. This is their website showing we're building this research program of 1 million people. If you'd like to join, it's open to anyone. Enough about those participants. Let's talk about what we're doing in the research area, right? So we're working around the mission to accelerate those health research and medical breakthroughs by nurturing relationships with those participants, catalyzing a robust ecosystem, so reaching out to groups that are so promising like yourselves to bring people in to use this data, and delivering the largest, richest biomedical data set ever, though from what I heard earlier, I'm not sure we're ever going to get there based on some of the other quotes. So let's push all those things aside and focus quickly on the DRC Researcher Workbench, which we're building here at Vanderbilt. Our aims from the grant were to get the data in, organize it, and make it useful. What's different about how AOU will share data is unlike a traditional approach where data is brought to the researcher. So if you want the Framingham study data, when I was a medical student, I wrote an application and was given, had to write out my statistical plan and what I was going to do with the samples, et cetera, and was given samples and did work in that. I had to store the data on my computer. That's kind of the old way. For AOU, all we want to do is bring you, the researcher, to the data in the cloud through a very low-cost, problem access method to reach that data in the cloud, giving you more compute, increased accessibility, and hopefully more threat detection and auditing capability. We have different tiers of data: public data that's generally aggregate, registered data that does have individual level data with privacy methodology applied to protect the participants, and then eventually controlled level data that will have more identifiable data like notes, dates, and zip codes. So what is this workbench? Where are you guys going to go when it launches in hopefully 12 months or less? After a quick data application, you will go in to find this researcher workbench, which again is based on Google Cloud, is running Jupyter notebooks with R and Python client support available. And let's work through a quick example. So what we hope happens is as you land at the Research Hub and browse public data, you can come through, sign up as a researcher, create your project, and output results or a publication there. So this is a bit of what it would look like walking through a project, and thanks to Robert Carroll for this quick example. When you create an example, for example, in diabetes, you would go in to create a cohort, which is supported by a GUI interface to use Boolean logic and select different conditions. So we're going to try to compare an A1C or blood sugar measurement between people with and without diabetes. And so as you use these drop-down menus to build your cohorts, you can identify people with diabetes, and apologies for the speed, I've hit my time, those with diabetes with an A1C measurement, and then make a control group, those without diabetes who have an A1C measurement. Pull that data into a notebook and do a quick analysis shown here, which, as has been mentioned many times, has the advantages of markdown, has the advantages of reproducibility, and generate a plot such as this one that shows that cases of diabetes do in fact have a higher A1C than those without diabetes diagnosed. And we've done this in the real data as well. We're not allowed to show all the steps yet with security approvals in place. So there'll be a lot more opportunities to do much more advanced analyses than these involving geolocalization with data as well. And there'll be integration to other data sets with pre-computed results and the ability to bring your own data to the cloud as well. So with that, I want to communicate to you guys that the promise and opportunity in precision medicine is huge. Please keep precision medicine and healthcare field in general in mind as you're looking to new careers. Please go to researchallofus.org and sign up for updates about data availability if you're interested in using the platform. And this great challenge still remains not just broadening our ability to observe, but supporting the need to make decisions in medical care. So hopefully we can take this information back to the bedside. We have a lot of projects in that area as well, but I was hoping to get you guys excited about the All of Us workbench that's coming soon. So thanks to the large data and research center team, as well as the huge group here at Vanderbilt that supports this work. And thank you for your attention. Email's there, and would love to hear from you guys. It's coffee time. Uh-oh, okay, yeah. Yeah, excellent question. The access policies are not limited to academia. In fact, participants wanted anyone to access the data. They said, when we asked, would you want pharma to access your data, for example, they said, if pharma can't access my data, how are we going to get new drugs? And so everyone will have the same access policies to agree to, including returning what you're working on so participants can see what's being done with the data. But anyone from academia, pharma, tech, nationally and internationally has the same right to access the data.